Find the range of each of the following function. F of x is 2 minus 3x, where x belongs to real and x is greater than 0. So for finding range, let f of x equal to y. Now, so 3x is 2 minus y. Now write x in terms of y. So you will get 2 minus y upon 3. In question, we are given x is greater than 0. So that means this 2 minus y upon 3 is also greater than 0. So multiply by 3. 3 is a positive number. So sign of inequality will remain same. So 2 minus y greater than 0 minus y greater than minus 2 multiply by negative sign. Y will be less than 2. So range in the interval form is minus infinity to 2, or in set builder form, set of those y where y belongs to real and y less than 2. The next part is find the range of this function f of x equal to x square plus 2, where x is a real number. So solution is let f of x is equal to y. So y is x square plus 2. Now write x in terms of y. Now this is a function of root of y minus 2. We know that this is defined when y minus 2 is greater than or equal to 0. So y is greater than or equal to 2. That means range is 2 to infinity, or we say set of those y where y belongs to real and y is greater than or equal to 2. Next question, find the domain of the function. F of x is x square plus 3x plus 5 upon x square minus 5x plus 4. We know that domain is those values of x for which your function is defined. Now clearly this is a rational function. This is not defined when the denominator is 0. So this is not defined when denominator is 0. From here you factorize this equation. You will get x square minus 4x minus x plus 4 equal to 0. We are going to have two values of x, either 4 or 1. That means this is not defined when x is either 1 or 4. So domain is all real minus except 1 and 4, or in set builder form, set of those x where x belongs to real and x is not equal to 1 and 4. Next, find the domain and range of the following real function f of x equal to root of x minus 1. Now this is a question of root. So for domain we write this is defined when x minus 1 is greater than or equal to 0, x is greater than or equal to 1, so your domain will be 1 to infinity, or this is your answer in the set builder form, set of those x where x belongs to real and x is greater than or equal to 1. Now as y is equal to root of x minus 1, we know that this is always greater than or equal to 0. Now you also write x in terms of y. You will get this equation. This is a polynomial function which is defined for all real values of y. But we have already this y is greater than or equal to 0. That means range is always greater than or equal to 0, or 0 to infinity. Close at 0, and we always have open bracket at infinity or minus infinity. Next question from miscellaneous exercise. Let f be the subset of z cross z defined by f is f of ab is equal to a plus b, where a and b both belongs to integer. You have to check is f is a function from z to z. Justify your answer. Now we are given f of ab is equal to a plus b. A and b both belongs to integer. Suppose I take a0 b1, then a into b will be 0. So that means f of 0 is 0 plus 1. Answer will be 1. In the same way, you take a0 b2. So f of ab, a into b is f of 0 is 0 plus 2. So answer will be 2. Now take a0 b minus 1. So f of 0 is going to be minus 1. That means now this relation is not a function because the image of 0 is not unique. Next question, let a is 9, 10, 11, 12, 13 and f from a to n be defined by the f of n is highest prime factor of n. Find the range. First you write all the number in the form of prime factor. 9, 3 into 3, 10, 2 into 5, 11 is already a prime number, 12, 2 into 2 into 3, 13 is also a prime number. So f of 9, the highest prime factor will be 3. F of 10, the highest prime factor will be 5. 11, this is also a prime number. 12, the highest factor will be 3. Then 13, f of 13 is 13. Now if you write the range in the roster form, answer will be 3, comma 5, comma 11. You write answer in register form only one time, comma 13, right?